Hi everyone. This lesson is putting everything that we've done the last couple of lessons all together. We can solve systems by graphing, and we're going to be using the slope-intercept form to graph today. Alright, so let's start by taking some notes. A set of two or more equations. We have been talking about different options for the same situation, and we've been writing different equations. So when we have a set of two or more equations about the same situation, it is called a system of equations. A system of equations. And when both of them are linear, we can actually just call it a linear system. So a system, two or more parts. So two or more parts. A solution, so when I ask for you to find a solution to the system, it's going to look like an ordered pair. An ordered pair. And that ordered pair is the coordinates that satisfies both or all of the equations, because sometimes it might have more than two equations. So it's an ordered pair that satisfies or makes both equations true. Or another way you can think about it is a solution to all equations in the system. And I know this part is not written in your notes, but you might want to add that. So there are actually different types of systems. So we know that it's an ordered pair that makes all true, and hopefully we found out in previous lessons that that point of intersection, this is the ordered pair that is true for this equation that is graphed, and is true for this equation that is graphed. So we can count over, here's my origin, and I can count over to name that ordered pair. So it is positive 3, 4. So the ordered pair, 3, 4, and I'm going to circle it so you can visually see where that solution is. This right here is the ordered pair that makes both true. And so we counted over 3, up 4, and this is the solution. Here, there's a line here, in case you can't see that very well, and a line here. So that point of intersection is where it makes both of them true. So 4, 2. You are going to run across some different types of systems though, like this one. Two parallel lines will never have a point of intersection. So in this case, we say no solution. And just so you know, sometimes you see, once you graph a line, and I'm going to just do this down here, it turns out to be the exact same line. So every single point is a solution. So we just say many or infinitely many solutions. So let's talk about if we are having to graph the equations ourselves. I was impressed with how well you've been doing with this. So describe a method you could use to graph y equals 2x plus 5. Well, 2 is the slope, or the rate, or m, and 5 is the y-intercept. So to graph it, we could place a point on 5 on the y-axis and go up 2 over 1 to get to other points. So I'm going to start at 5 right there, and I'm going to go up 2 over 1, up 2 over 1, or remember I could go down 2, back 1, down 2, back 1. down 2, back 1, and then hopefully, now that you are going to be working for accuracy, which is very difficult here, you will use a ruler and draw that straight line. So here, remember this -2 is my slope, the -3 is my y-intercept, so we can place a point at -3 on the y-intercept. And go down 2 over 1 to get to the other points. So we're going to start at -3, and I'm going to change colors. So we're going to go down to -3 on the y-axis, and we're going to go down 2, because it's a negative slope. Remember, our line has to be going downhill, up 2 over 1, up 2 over 1. And actually, if I do this many times, it crosses at an actual point that I am plotting. So right here is my point of intersection. So that is at, we have to go over -2 and up 1. So the solution is -2, 1. So what does that mean? That means the point -2, 1, what that means is it makes both equations true. So I could plug that back into both of the equations. So that first one, I'm going to plug 1 in for y equals 2 times -2 plus 5. 2 times -2 is a -4 plus 5. That does equal 1, so that works out. And then I could go to the second one, plug 1 in for y equals -2 times -2 plus 3, and -2 times -2, I'm sorry, I said plus 3, it was supposed to be -3. -2 times -2 is 4, minus 3 is a positive 1. So that checks out. So I know that this point, -2, 1, is a solution to the equation because it makes both of the equations true. So it's a solution to the system because it makes both equations true.